Greg, are your model runs done?
What's that?
Are your model runs done?
Your James stuff?
The model runs are only out to 48 hours or so.
The 60 should be up there, right?
But the other one's done.
Are they working now since I...
Yeah, they seem to be working.
I'm having issues with my Python end of things. The thread server is throwing back not a numbers for sometimes just randomly. And I can't figure it out.
That's in triple
Up,
A.
up, up,
We
up,
just
up, up.
heard.
It's right around pivotal. There you go. Triple James down now. There you go.
No, that's model.
Oh, you want to see the model run?
Yeah.
Oh, that would be cup. .AOS. I don't think these are on there. Or maybe they are. Cup.AOS. That was steady to you. And then North America.
You got it.
Yeah.
12 G's out to about 48 hours.
We have a Zoom in for the speed.
I don't know. Do you have a closer? No. I guess we're still getting ready for those of you on the stream. We're just waiting for a second.
Wait a second. GFS initialization. Oh, it's old.
It's not out that far yet. Try 48. Valid 12 p.m. Sunday. So that's kind of what we can look at that later. It'll be off Friday by the time you go. So you ready? Right.
Oh, wait, where's the...
That's all that's
Okay, welcome to Weather Watch today. What we're going to be looking at today are, well, what's up right now is actually the first flakes of the season that began early this morning, and we've had some snow showers passing through the area. We'll talk a little bit about this, the weather system that produced this particular event, and then most of the focus of today's discussion will be on looking at the setup for our first potentially accumulating snowfall here in Madison for the season. You know, we could be looking at anywhere from 1 to 3 inches or perhaps a little bit more of snowfall beginning early Sunday morning and lasting through midday Sunday. But first, again, this is from the rooftop camera looking to the north. This is a 1-hour loop.
This is actually starting earlier, so
Okay.
there was some better snow earlier this morning.
So this is actually starting earlier today,
About 9 o'clock.
around 9 o'clock or just before 9. And you can see clouds coming through and then visibility is decreasing in snow showers that we had. And but obviously we're several degrees above freezing, and it's not particularly heavy precipitation, and so we're not seeing much in the way of, or no accumulation, I guess, at this point.
Rich Saline City had a drought on the southwest side this morning.
Okay.
We had, on the way in, I saw some aggregate flakes, some needle aggregates, and they were pretty big flakes coming out for a short burst.
So what's the temperature range for those?
It was about 30 to 34.
34.
Well, the only temperature range where they form.
Where they form, yeah.
Oh, those, they will, they require up to minus 12 to minus 15 for the, I'm thinking of dendrite.
Dendrites are like
No,
minus 12
we're
to
not
minus
seeing
22.
dendrites, so we were seeing needles. Needles are 0 to minus 5.
Okay. So we're going to be getting colder than that, so we may actually see some better accumulation. What's that we have here?
It's just the west one. No, it's water accumulating on the camera lens.
Okay.
I wasn't sure if the west would be any cooler. It's not coming in yet.
So yeah, so we have these loops. Pete has them posted, and kind of great just to see when weather's coming in, what's going on, but the visibility is dropping. And this will perhaps, as we'll see with the radar, go on from time to time during the afternoon, but I think the bulk of this is over for this particular event. So we'll go to the first tab, which is our climatology, I believe. First, yeah. So this is from the state climatologist office, just showing where, the yearly or annual cycle for temperatures has been updated just recently. And you recall earlier this semester we were well above normal. Then we shifted to something with a variation in temperature which is close to normal, although in the last week or so we were back above. And it's like we'll be trending toward below normal. So our normal daytime high this time of year is in the mid-40s. Overnight lows just below freezing in the middle of the 20s. And so we're going to be moving back into that range, or maybe slightly colder than that over the weekend, when we're going to see high temperatures barely getting to 40 degrees. So it's a chilly weekend coming up, but we'll see that in the forecast. Next tab, please. So this is our current visible satellite image. And a couple things to note. Again, this band of cloudiness is producing moderate to heavy rain in the northeastern part of the United States. You can see the leading edge of this. We looked at this in 452. So this band of precipitation was in fact associated with a cold front that moved through, and we were diagnosing that frontal circulation, cross-frontal circulation yesterday in our lab. This really nice, vigorous dry slot that's come around behind the large-scale circulation associated with this. And it's really neat to note this, again, this edge to the cloudiness. We have our sort of warm conveyor belt type structure, but you can see these clouds that are emerging from below these high cirrus clouds that are kind of being diverted around this large-scale cyclonic circulation. And we'll see that when we look at the IR image. You'll see that noted marked pretty clearly.
We'd be able to see that in the day cloud type image as well, with the different colors, the reds and yellows.
Okay, so we can try that. So Pete's suggesting there's another tool that allows us to see
day cloud phase distinction.
day cloud phase distinction.
So the yellows and the reds are up higher, and the light blues are down lower. Like this stuff is all really low cloud.
Right.
It's a little higher. And the real dark blue is land, and the black is water, typically.
Right. So we have this large swirl of low cloudiness. There are a few areas where it's embedded higher clouds, and we'll see these are associated with some modest short waves that are rotating around the larger cyclonic circulation. But we're going to expect beneath a large-scale cyclonic circulation like this, some weak Ekman pumping, which could lead to convergence in the boundary layer, and if it's moist enough, sufficiently moist, you might get a little bit in the way of precipitation. And then associated with that as well, these small short waves that are embedded in this larger scale circulation can provide a little bit of additional lift, if you will, to enhance the precipitation in certain regions. And we'll see that when we look at the radar. But again, the biggest events that are occurring, the rain in the northeast, these showers that are occurring over the upper Midwest. In our forecast city, we can check out the latest ops from Saginaw, from FBS. But they've had light rain, so far no official accumulation. They have to get to at least 1/100th of an inch because, well, that's what I forecast, so I want to at least have that verified. But if you want more than 1/100th of an inch, you'll be in pretty good shape. And then we have these clouds here. That's really it. In the Pacific Northwest, we see some clouds moving in, and we see there is precipitation. We'll see on the radar. And it's the weather system that's just off the Pacific coast, just to the west of British Columbia, that's going to be our snow producer, or likely our snow producer for the upcoming event on Sunday. Let's go to the next tab, please.
I was just going to say, the reason why this shows up real red when it's dark out, this is a day cloud phase distinction. It uses an infrared channel for the red color, and it uses visible or reflected channels for the blue and the green. So when there's no sunlight, all you get is the information from the infrared channel, the red channel. So if it's dark, everything will be red. And then as the sun comes out, you'll start to see these colors. There's a night cloud detection type recipe also that I'm not currently plotting to go. Trying to figure that out.
Right, and also here you can see the snow in the mountains.
Yeah, bright green is usually snow. So if we have a snowstorm go by, you can see the snow track a lot of times in bright green.
Yeah,
Yeah,
great.
I have a question. What do you think that boundary is with all the convective storms, like over the Bahamas there, all the way up and down? Those all seem to be forming along some kind of a boundary.
This may be actually
Is
where
that
the
the warm
surface cold
front?
front is. I think the surface cold front, I think, is down there.
Okay, surface cold front.
Right.
So those are cold front storms.
I believe so. Unfortunately, I don't think we have the OBS plotted here to see what will be analyzed in this region. But the front yesterday was, I don't know if some GeoS has been progressing pretty steadily to the east. But maybe we'll find an analysis that shows that.
So all that air moving from the southeast to the northeast, or from the southwest and northeast over the continent, that's all post-frontal air. I'm thinking
Yeah.
over Tennessee and
Right.
Louisiana. Yeah.
This area right here.
Yeah, all that air there is post-frontal.
Right.
Okay, included.
Yeah, this is, I think, would be characterized as a occluded cyclone on a surface, surface analysis for this. But the reason I was showing this was, again, that really visible cloud edge. The next tab that we have is a IR image. That kind of shows that really sharp edge as well. But again, you get the sense that there's another stream of air that's emerging from beneath this and rotating cyclonically around this particular setting. Greg noted that, at least on the planet as of this morning, there are no active tropical cyclones, which is kind of neat. I think this is the remnants of one that we were looking at last week that's kind of stood around for a while, but it's no longer labeled as a tropical cyclone. Let's go to the next tab, please, Steve. Which should be the radar. Nope, surface map. Here's radar. Here's radar. So here's the radar, and you can see the precipitation exiting the northeast. They had some moderate rain, heavy rain in Albany this morning. It's still going on. Just about to end. It's now in the moving into western Massachusetts and into Vermont. That area of cloudiness we saw post-frontal is shows up with some precipitation across the approaching Tennessee and Kentucky. And again, you can see these enhanced areas of precipitation under this broad cyclonic circulation. When we look at the upper tropospheric analyses and maps, you'll see there's some small short waves that are associated with some of this precipitation. And again, this next area of showers approaching Saginaw area, we need a little bit more precip for them during the day today. All right. Yeah.
I was gonna say, I just checked on the YouTube. Andrew Quigley is watching with us this morning, and he said, about 10 minutes ago, he said, he believes there may have been some lake effect snow showers off the northern shore of Lake Winnebago this morning. Surface winds are south to southwesterly across east central Wisconsin at the time, so petrolly maximized. Collapse rates were dry adiabatic over the lowest 250 millibars in the troposphere, as well as surface temps in the mid to upper 30s, 850 temps near 20. So,
Get a close-up radar to check that out.
thanks, Andrew. Show up on this right. Lake Winnebago is kind of right. I guess it'd be on the northern edge of this. Maybe this doesn't go back far enough to see.
Okay. Did you say what time that was?
He did not say what time it was. He just said this morning.
Around 9.
Yeah, hard to say from this one. We have to go back a little further and correct this.
Yeah, so we appreciate the comments we're getting on YouTube. Keep those comments. You can really see nicely the showers that are developing, again, ahead of these weak disturbances that are coming around. Okay. And I guess this is over Lake Michigan, maybe a little bit of lake enhanced precipitation moving into western Michigan. Okay, let's go next to the surface analysis. We'll start in the northeastern part of the United States. Or, as you can see, Albany with light rain, 56 over 55. Some moderate rain in Concord, New Hampshire, 52 over 50. And pretty stiff winds off the Atlantic and southeastern New England with winds 20 knot winds or so. Headed this from the south. And you can see a nice shifted winds more from the west as you get into central New York State and down through New Jersey. But front is pretty much right through here. I guess this would take it pretty much offshore, Greg. So it might be consistent with what we saw down over the Bahamas. Those winds obviously hasn't reached Bermuda yet, but the east wind is such a...
I wonder if that would be considered an included front all the way down there into the Bahamas.
I think this is probably still cold front. The included part of the cyclone, I think, is way
The
back.
cyclone, yeah, but it could be an included front if there was a warm front at one time, I don't know.
Yeah, the warm front was pretty indistinct, but it was more over the continent at our latitude.
Yeah.
Okay. Southeastern United States, really nice with low dew points in 30s and 40s. They get down to far southern Florida. You see there's a nice gradient in dew points there. I guess the front gets whatever's the remnants of it offshore is pretty diffuse. But you can see there's still a dew point gradient, so there's some drier air there. And not really much cooler down over the Florida Peninsula. You come back up to the upper Midwest. Again, Madison 36 over 32, so a pretty chilly day. Again, normal high temperatures would be in the the middle to upper 40s, so we're about 10 degrees colder than normal at this point. Closer to the lake, where it's just a little bit warmer, even with a west-southwest wind, it'll go off to 39 over 33. And go to the northern part of our state, temperatures, well, still holding in the upper 30s or so, but the colder area is much deeper back through here, so it's going to be largely frozen precipitation. And the rainfall we saw approaching the eastern parts of Kentucky and Tennessee, 47 and 42 at this station, don't know the name of it, but 47 42 with moderate rain. That disturbance. That's a curious feature that's producing the precipitation. It's isolated band of cloudiness, and maybe we'll be able to see something to diagnose it. Remember that when we go further to the forecast. All right, so that's a look at the surface. Let's now head up to the upper troposphere.
Andrew just followed up and said it was around 9 to 9:30, and he thought maybe they were lake effect just because they sprouted up quickly and collapsed.
Okay.
Let's see where.
I think the next tab will be
Yeah, I'm not sure.
a little bit more organized than normal. We'll start at 250. Please. So again, you can see this really impressive upper trough, fairly deep upper trough over the central part of the United States. We can see the, again, really nice change in curvature from cyclonically curved flow across the southeastern part of the United States to this sort of southerly flow that becomes more anticyclonically curved once we get into eastern Canada. As we see, the surface low is located just north of Wisconsin near Lake Superior, and it was in a position earlier to have really favorably deepened. As we look at this change in curvature, there's going to be certainly lots of large area of divergence expected in southeastern Canada at this point. The next feature that's going to be of interest is this really relatively strong jet. Looks like 135 knot winds in northwestern Pacific Northwest associated with this jet that's just getting to the west coast. We saw a lot of precipitation with it. There is some moisture with this, and we're going to watch what emerges from this jet in the forecast as it heads east and then southeast over the Rockies into the central part of the United States. It'll be developing in that feature. But this cyclone is pretty much maxed out in terms of its deepening. Next clock, please. If there are questions or comments, please ask. Or join the conversation. 500, please. Yeah, thanks. At 500 hectopascal, again, this looks pretty much the same as what we saw at 250 millibars. Really strong jet across the Central Pacific into the British Columbia coast and Washington coast. Nice ridge, fair weather there. Strong divergence anticipated in this region with a large-scale area of convergence in the middle upper troposphere located over the plains. And then again, this broad cyclonic circulation, it's going to have an impact at the surface with that surface convergence and that's been pumping beneath it. That's going to help with the low cloud that we saw on that swirl. It's not totally obvious here, but if you look, you can see abrupt wind shift between the Twin Cities and Green Bay. You expect that the cyclonic curvature, but there's a little bit of a vorticity maxima that we might diagnose back through parts of southern Minnesota this morning at 12 Z. That's been slowly rotating around this particular feature. And yeah, so that's, I think, one of the reasons you see that enhanced area of precipitation over us this morning for our southeast. As this feature has been rotating around the upper trough. Most of the vorticity analyses themselves might be able to pick that out a little bit better.
Can I point?
Yeah, sure, please.
I was just looking at the total jet stream all the way up, and where you have that ridge going up on the west coast, well, inward, over Montana.
Yeah.
That ridge, the loft, that seems to be one of the first instances we've had. This is starting to connect up with polar night jet above. There is a polar night jet.
That's this
swinging
latitude.
through, it's swinging through kind of about the latitude of Alaska, central Alaska, and then south along the latitude line.
Okay.
So this ridge is intersecting, the jet stream there is intersecting, starting to intersect with that. I don't know if that's giving it an extra push from what we've seen recently this fall. It's the first instance, I think, over North America where I've seen this going on this fall.
Is this associated with a plume in terms of the ridge here? Is that
I
true?
mean,
Do you want me to
there
go
might
to your
be, I mean,
page?
Let's go to Greg's page.
Let's get the first frame there for 12Z this morning. So you can see the jet,
So this is the polar night jet.
that's the polar night jet up there, yeah. And then we have this ridge.
Ridge.
The
And
jet's
so this
right there. And you can
is,
see the cutoff over central US.
right, so what's shown here, the coloring here is, or this band right here is the subtropical jet. And the coloring here is colored by the potential vorticity. Right. And then this lighter feature is a jet that's typically located much further up in the atmosphere, the polar night jet.
That's up about 25 kilometers.
So it's about 25 kilometers here, associated with the polar night jet. And what Greg was mentioning is that this is one of the first instances this season that we're seeing some connection or very close proximity of the subtropical jet and the polar night jet.
I think that's, I mean, I don't think there's anything in the literature really discusses this, but I think it's significant. I just, you watch throughout the winter, when we see these intersections, that sometimes the subtropical jet will go right underneath the polar jet completely. And look what it's doing off the east coast there. You see that? Right over Europe now.
Yes.
Yeah, that's later on in the week. But those kind of intersections seem to create weather. And
Okay, so that might,
speculation on my point, but I think we need to keep watching it.
okay. And one of the things to note about this, again, it plays into the weather event that's going to emerge over the next couple of days, is the trough that's out to the west of us. We stop that loop at the beginning, please. We have this jet that's moving to the northwest. This feature, over time, gets more energetic as it moves into the central part of the United States. And it's unclear what, from the diagnosis I was looking at this morning, what are some of the key
Look
factors?
at the southern hemisphere polar night jet through the end of this loop. Watch
Right.
that. It's really on its last leg,
It's still pretty active at the beginning.
Watch it to the end there. It's just, look at that, it's starting to.
The Greg's noting the sort of collapse of this jet across the southern hemisphere around the Antarctic.
It's late in the year for that to happen, but it's finally seems to be. And at the same time, we're building the one to the north.
All right, so we'll go back to 850. Down to 850 millibars. Again, we can see this. At 850 millibars, there is our nice upper lobe. It's just right over just to the west of, north of La Crosse and east of the Twin Cities. You can see this thermal ridge that extends all the way back. That's another characteristic structure you might anticipate with a, fluid system, fluid cyclone. And at 850, the front, the 850 millibar front, is just between Wallops Island and, near Islip on Long Island, and then goes offshore. So that peak in the isobars also shows up pretty nicely with that. There is some more enhanced baroclinicity across the main front, at least at the surface, I think, as well to the east. But there is some enhanced baroclinicity across parts of the Missouri, southern Illinois, approaching western parts of Kentucky and Tennessee. And it might be, if this was genetic, there is a bit of confluence in this region with that horizontal temperature gradient. That could be responsible for that area of precipitation and cloudiness that we saw approaching that part of the country. So it's something to look at, perhaps try to diagnose that. And again, looks pretty innocuous. There is a trough located just off the west coast. But again, it's from this, what appears to be a data void region, but there's certainly satellite data that goes into this analysis. There is a feature that's going to emerge from this that looks like it'll be the key to our snowy forecast for Sunday morning. Okay.
Well, one more
yeah.
thing, that ridge over the west coast, is that setting up a fire situation in the south, on the southern west coast?
And the ridge here?
Yeah, south of San Francisco, between San Francisco and San Diego. You can see they were getting some
There's
northeast
also
winds in there.
right. Yeah, so there's offshore flow, so Greg is noting the fact that with higher pressure over the basin in the western part of the United States, just over the Rocky Mountains and a little bit to the west of it, is this setting up a flow, with this offshore flow, that's a relatively dry flow, that could lead to this downsloping warming. Could that trigger fires? And I guess this time of year in the fall is when sometimes fire weather.
Yeah, this
becomes
is
significant.
a season for it. We had it earlier for other reasons, but this might be getting to more of a normal condition this time of year. Also, at the same time, currently going on right now, I guess in Central City, which is at a higher elevation than Denver, it's about 9,000 feet. Just to the west of Denver, they're getting some high winds today, and they're looking for high winds for the next 3 days. So those may be kind of mini downslope windstorms that aren't reaching to the elevation of Denver yet, but they're at higher levels. So you probably see, at this point, you probably see some lenticular clouds on the east slopes of the Rockies. The wave clouds coming off from there. So that high pressure is affecting both directions.
So, maybe windstorm conditions over the Rockies west of Denver, but also with higher pressures here, that's going to force an offshore flow, and that could lead to.
The winds are still easterly over Denver there,
Right.
but above them, we're getting the higher winds, and then later on in the fall and winter, that'll penetrate the surface.
Maybe next week it might be good to talk a little bit about the windstorm setup. Good, that's a good thing. Okay, so let's now go to the next tab, and that should be the time series for the weekend weather coming up. Again, for today, temperatures basically falling from 12 to 8, kind of stationary, steady early during the day, and then dropping off tonight. That cold advection, recovering to just above freezing tomorrow, and maybe on Sunday getting about as warm as they are today, upper 30s, middle upper 30s or so. But we'll notice a little bit of light precipitation forecast by the model, and then some enhanced precipitation starting late or after midnight on Sunday. This doesn't put out a lot. It looks like, according to this, most of the precip that we get is just little bits, bits of precip over from 12 to this morning for those snow showers, and then a little other burst near the end of the period. But I think when we look at some of the operational models, we're seeing a slightly different story. But this kind of paints the broad picture, and we'll look at the details by focusing on the different models. Let's go to the time height section. A lot of interesting things that show up here. Here's that deep trough that's over us, manifest by the dynamical tropopause in the time height section as a lower tropopause. Here are the isentropic surfaces that kind of pull upward underneath this upper trough. That upper trough by later this evening moves on to the east of us, and the flow begins to relax a little bit, but we maintain this northwesterly flow. Relative humidities in the column stay relatively high through tomorrow morning, and there may be a brief period where we kind of clear out, so there might be some breaks in the clouds tomorrow. The sun, you can also notice that there's perhaps subsidence occurring here that may be very weak, but you can see the temperature, here's some subsidence evidence of that right here, explicitly with downward vertical motion. But you can see the isotropes beginning to sink back down, so that's going to be associated with warming in the middle troposphere, stabilizing things. But then, you notice the dynamical tropopause reappears here, so this is another trough that's approaching. That's the system that's off the west coast right now. As it approaches, lots of cooling in the column. That cooling has to be associated with strong ascent. Even in the face of these veering winds with height in the lower troposphere, that ascent is leading to some cooling of the column. It's going to overwhelm the warm advection. With this, with the column beginning to moisten up and deeper layer of moisture, that's going to be consistent with our beginning to get some precipitation. This forecast actually keeps the winds southwesterly, westerly, and eventually northwesterly. Just from the pattern of the surface winds here, this would suggest a track of this surface low to our north, which is not the most favorable one for snow. I believe this is initialized with the NAM. We'll see the NAM forecast has been somewhat consistent with trying to take the surface low that we'll see in the forecast to our north. GFS, UW-AOS, some other models take it a little bit further to the south. This is going to be kind of an interesting conundrum as to which track actually is followed, but that's going to determine who gets the most snowfall. So let's actually look at the evolution of surface maps first, then we'll look at a few other maps after this. So let's just step through. Here's the 6-hour forecast, valid at the beginning of the period. Again, here is a heavy rain, the accumulated precipitation through 18Z today associated with that frontal passage. Here is this broad swirl of light precipitation and snow shower that we see here, with some lake-enhanced precipitation forecast by this model right along the northwestern shores of the peninsula with Michigan itself. Okay. And a little bit of light precip roughly in the area where we saw the precipitation occurring this morning, but not as widespread. Let's go, please, 12 hours ahead to midnight tonight. The front continues to progress offshore. Again, light showers still expected in this region. I believe that feature that we saw heading to the northeast in the clouds, and we saw it in the radar, this broad area of light precipitation that fully shows up here. And you can also notice that it's just following a secondary shift in wind. You can see this little trough right here. That's perhaps associated with a weak, maybe a secondary cold front, which was perhaps suggesting might be the case. But the cyclone is beginning to move into Canada, so again, pressures are beginning to rise over us as it lifts away. And watch what happens out to the west of us. Let's go to tomorrow, 18Z. By tomorrow, 18Z, and some remnants with a flow across the lakes, a little bit of lake enhanced or lake effect precipitation. We're cold enough for snow at this point, with cold advection still continuing. And we see this feature emerging from Saskatchewan, whether we call it a Alberta Clipper, a Saskatchewan Screamer, or a Manitoba Mauler. Come up with names of all sorts of things. This feature is going to be heading to the southeast. You can see the warm advection ahead of it, cold advection beneath it, northwest west. This feature is going to track along this baroclinic zone. As we go head down 6-hour increments, we can see the evolution of this. This is valid midday tomorrow. Let's go ahead, 6 hours. Light area of precipitation, mostly snow in the Dakotas, headed toward us. We saw in the time height sections, clouds will begin to increase later on tomorrow afternoon and evening, so we'll probably already have high clouds in the area. Warm advection is beginning to start out to our west, kind of neutral advection over us, disturbing neutral advection. Let's go ahead another 6 hours. And this model does not, 42 hours, it develops a cyclone in central Minnesota. Let's remember that for midnight on Sunday. The low is forecast by this model to be up here. And light precipitation just on our doorstep to the west with this particular cyclone. If we look at, let's go down and look at the 700 millibars, not 700 millibars, the Q vector map at that same time at 42 hours. A nice area of Q vector convergence located to our west. You can see the orientation of these Q vectors and the isotherms is suggestive of perhaps continued amplification of this thermal ridge to the west, but the convergence of it is associated with the precipitation area that we see in this region. So we have some forcing for ascent just to our west, and let's look at that first 6 hours later for this same map, and then we'll look at the surface map. So 48 hours of Sunday morning, we have that nice Q vector convergence pretty much right over us. We'll see that we'll be moist enough, but the question is, or we'll have some moisture over us, will we be moist enough to get significant precipitation? Will this vertical motion, if we were to invert this and solve for omega, it would be significant. Let's look at the surface map at that time. And it has a pretty floppy, flabby low located to our north. Again, there's broad area precipitation, but it's not, there's no organized, there's a cyclone here, but it's not perhaps the most impressive one that you've seen. In the past, you can see there is some cold advection to its west, very weak warm advection east of it, but this is not a really robust signal for a significant snowstorm, and that was borne out by the precip totals we saw for Sunday morning into the afternoon. One more map time after this. 54 hours, pretty much a trough. That weak cyclone moves eastward. Precipitation gets a little bit more energetic as it gets east of us, but this is not an impressive development. So this one model simulation takes the low to our north. We get some light precipitation. Yeah, not something to get particularly excited about. But in the wake of it, northwest winds drags the cold air back in over us until we stay chilly into Monday. So we'll extrapolate this. Let's look at a closer up map. We'll go to the local maps for the nest. We'll go to 36. Let's go to 42 hours first. So this is at midnight Sunday. Again, the snow just to our west, probably already arrived in Middleton. But this is an area of really light precipitation over that 3-hour period, no more than 5/10 of an inch. So these areas are probably getting to half an inch of snow, being a 10-to-1 ratio. You can see there is a broad area of warm advection. Okay, kind of maximized in this region, and that's consistent with the Q-vector convergence. We know they're related. And the localized warm advection is going to be one of the terms that contributes to that Q-vector forcing. And that shows up nicely in this region. Let's go ahead 6 hours later, so Sunday morning. $40. 48 hours Sunday morning. Again, we're in this broad area of light precipitation. There is still some warm advection ahead of this. This is not frontogenetic. We don't see the front normal component or the isotherm normal component needing to decrease significantly. Maybe some very weak frontogenesis to our south. But this is, again, really not the most exciting pattern for maybe give us some steady light snow, but nothing that's going to be pretty good for it. What I want to do is just shift models. If you don't like one solution, look for one that gives you more snow, perhaps. Kind of joking, but let's go to the pivotal site. That's the next tab. Okay, so this is this morning. We're going to quickly, let's just step through this this sequence of maps pretty quickly. Let's go in 6-hour increments just to follow how and what's happening here. Here's the cyclone that's beginning to depart to our north. 12 hours later, it's weakening, moving rapidly to the north. We have a trough behind it that comes through. There's that precip in the Kentucky and Tennessee. And we'll go ahead again, another 12 hours. And again, northwesterly flow, we're now into actually warm advection at this point, and the coldest air is now to our southeast. We have this feature coming across the Rockies right now with a weak cyclone at this point. Let's go ahead to tomorrow morning. Light snow beginning to break out in the Dakotas, but still for us just a northwesterly flow with neutral temperature advection. 36 hours. Let's jump to 36 hours just to quickly get through this. So here's the cyclone beginning to emerge. Now notice in the GFS forecast, it begins to develop a cyclone. Let's actually go to 42 hours because that's when we saw it in central Minnesota in the NN5 forecast. It's a little bit further to the southeast, further south. Okay. You can see a nice thermal ridge that's beginning to develop to its east, thermal trough to its west, so this looks more akin to a developing cyclone than what we saw in the NN5 simulation. Broad area of snowfall that's out to its east, and a little bit of rain to the south where it's warm enough for liquid precipitation. We'll go ahead to 48 hours to Sunday morning. This develops. And a surface cyclone has tracked southeast from southern Minnesota, just over southern Wisconsin at this point. And there's going to be one question is, I mean, the precipitation looks pretty robust over us, maybe a burst of snowfall Sunday morning. But we're pretty close to the freezing line, so we want to watch that. Let's just take a sounding right over Madison. Check things out. Okay. And so for this, it is pretty moist. We're below freezing at the surface. We're actually saturated at the surface. There's our 0-degree isotherm, so we're definitely cold enough for liquid precipitation. In the region where we might expect to see, or would like to see, the atmosphere saturated and have robust vertical motions, so-called dendritic growth zone for these big flakes of snow, it does appear that we are a little bit undersaturated, right? It's moist, but not super moist.
You can get big flakes of snow around around 0 to -5.
Right, but it's not, I think it's, isn't it -10 to -20, that's the key.
That's where you get there's two kinds of aggregates.
Right.
You get the dendritic aggregates up higher, -12 and -15. But below, you can get Kalamazoo multiplication, which creates a zillion needles, and then they're very sticky. So you get sticky clouds of needles between 0 and -5, probably -7, -8. In that
Okay,
region.
so in this range. But even down here, when you get to -8 or so, we're kind of subsaturated. You want a little bit of supersaturation in that layer, right? With respect to liquid water.
Well, I don't think, yeah, you would, because you need the cloud droplets for the process, so yeah. You would think that.
So it's not ideal, and we can step ahead 12 hours just to actually, or 3 hours, next time step ahead, we get that moistens up a little bit. And it does to some extent, we moisten up a little bit. And so there's gonna be a period on Sunday morning, probably between 12 and 15D, that things begin to come together and it looks a little bit more dramatic in terms of precipitation over us. And snowfall rates perhaps beginning to pick up. But the key thing is we're definitely cold enough for snow. Surface temperatures are just about freezing. The ground, which has been relatively warm until just recently, is still kind of warm, so it has to come down at a pretty good rate, perhaps over grassy areas and objects that are cold above the ground to actually stick significantly. But there's another aspect of the storm that's really interesting, and we noted this yesterday in our 452 class in our discussion, and we can go to that GEMPAC script. This weather system, and we'll come back to the GFS pivotal page in a little bit, actually does develop right over us. You go to up arrow to WD, HD, yeah, that's it. So this is a script that's going to show the 500 millibar height falls over a 3-hour increment with the 500 millibar heights. And so this is just simply a difference in time of heights at one time minus heights at an earlier time, 42 to 39 hours going back. And what you see, if this were simply a wave that's propagating from west to east, you would see an area of height falls ahead of the wave, area of height rises behind the wave. We see those height rises, but they would be symmetric. This is suggesting that this upper trough is actually beginning to get more active, get more significantly stronger over this time period, because we have the height falls almost co-located with the trough axis. If we rerun this script using the numbers, say 48 to 42, let's actually keep the same, 48 to 45. So first number will be 48, second number 45, third number 48. The height falls between over that 3-hour period at 500. Let's do 500.
Did you get that right? The 48, 45, 48.
Yeah. No, this last number is 500 feet. Just the height, though. Not at 500.
Just 500?
Yeah. So this is for the, in the script that I had, this is the time difference between 48 and 45. I want to plot the heights at 45, or 48 hours, and then you see it with a map next behind this. Again, there's no obvious dipole associated with this. This is really just propagating along and amplifying, or just amplifying. The height falls are right in the trough axis. So this is something that is beginning to get more energetic as it crosses our longitude.
So that's the QG circulation on the polar advection side of the trough.
Right, so I think the polar advection at the surface beneath this 500 millibar layer is leading the height falls and helping to amplify this particular disturbance. Let me do one more time, 51 to 48.
Before you do that, you can also see the shortwave trough up ahead of the main trough.
This right here, yeah, so this little feature as well as deepening. So this whole environment is one conducive for height falls. One of the other things that's a little bit destructive about any of these features is when you have, I mean, this is not a particularly impressive trough. It probably would be better if we didn't have this feature here, because then we'd have, it would be nice to see height rises ahead of it so we get a much more cyclonically to anticyclonically curved flow. Also, most of the height falls are well to our south, and so the surface cyclones can be a little bit further to the south. But we don't want this to trend too far to the south so that we get most of the heaviest precipitation south. So we'll do 51, 48, 51, and 500 millivolts. So these are 3-hour height falls. I'm just trying to see how they're located associated with this particular. So this trough really is going to town. The base of it is really getting stronger to the south. That other weaker trough begins, looks like it's beginning to sort of collapse a little bit. And then height rises begin to curve more or less. But, you know, this would suggest if we were to look at the accumulated totals, we're probably going to see heavier amounts to our south, not that broad, kind of very spread out light amounts that were across Wisconsin and northern Illinois. So let's go back to the pivotal page and take a look at the evolution of that. And we'll zoom in as well. We'll change the region so we can just focus on that in the last one. X that out. Click on instead of continental U.S., do region. Click on the U.S. and then the that one, yep, Midwest. And so this is at 48 hours. Let's step ahead 3 hours to 51 hours. Evening. And you can see downstream of where we saw some of the highest height falls in the GFS, and I was using GFS data. Downstream of that is where we're seeing some of the heaviest precipitation rates associated with this cyclone. But notice the cyclone tracks right along the Wisconsin-Illinois border. That's not too bad. With that. And the cold advection, west of it, is beneath, very close to the proximity beneath the 5-day polar trough, which is going to be associated with height fall. Let's go ahead and one more click. And that moves over Lake Michigan, and we still have some residual light snow that's expected over us and the counties to our east into Sunday afternoon. How much do we get from this? And we'll look at a couple different model runs, but if you can scroll down, 10-to-1 ratio. Let's go to 24 hours just to get rid of any of the residual snow that we're getting. Not 24, I'm sorry, go to, you can go Monday morning, 72 hours, and then look at the 24-hour snow amount. So this is this is giving us about 5 inches of snow. Even though they're getting higher amounts to our south, I think a lot of this comes at the very end of this period. That's the 24-hour accumulated amount. If we go back, snow's going to be over by midday, so by Sunday night. You can see that ground warmer to the south, so it's take a while for it to accumulate, but we're getting a pretty decent amount here, on the order of about 4 or 5 inches.
I would suggest you look at those amounts for the last 4 or 5 frogs in a row.
Right, so we can look back at this. That's just my break. So this is the run from last night, 6Z, giving us, again, this is accumulated through Monday, 24-hour accumulated through Monday, through Sunday night, so 6 p.m. on Sunday, 0Z Monday. Go back another one, 3.9. This is what got us excited during Weather Watch yesterday. We saw this big amount, 5.9 over us. And we'll go back maybe a couple more clicks just to see how this has evolved. 2.9, so trending to the north. And then finally, 60 yesterday. So amounts have been varying, but it looks like we're kind of in that around 4 inches at the end of this, but how much that melts because the ground is still relatively warm. Let's go to, click on this for animation, but we're not going to animate. We're going to go to model comparison loop here. And then we have all the models valid at the same time. Let's go to the most recent models. So 12Z runs. They're all valid at the same time. This is the Canadian model. GDPFS has a strip of the heaviest snow right across our area, or just to our north. Go to the GFS, same time period. Kind of a similar sort of track. This is the 12Z GFS. Looking at a little bit more to the south over northern Illinois. The NAM, much weaker. Again, it has a band of it located more to our north. 3-kilometer NAM, kind of a noisier view, but has a strip over the southern 2/3 of our state. RDPS, that's what the RDPS is, but that also has the heaviest precipitation to our north. Lighter amounts down here, and then finally UK Met model has a track which is presumably going to be well to our north. Hardly gives us anything. The MM5 was somewhere in between those scenarios. Just to kind of verify if we can bring out the surface map for this one. This is the UK Met model. To see how tied to the track of the cyclone is the precipitation amount. Let's go back to 48 hours and see where that cyclone was. And let's go to the UK Met shows up. What doesn't? RDPS. So if you just drag it along, we can see different locations for the cyclone. Here, the cyclone's kind of right over us, and the 3-kilometer NAM, the regular NAM a little bit further to the north of the cyclone center. H-Ward has a very light precipitation. This is Sunday morning, just right over us with a much weaker cyclone. This suggests maybe even liquid precipitation, and that's from the FP3 high resolution model. North RW has a cyclone, again, roughly our latitude. And her is not really even a cyclone center, it's just a baggy trough that's to our east by this time period. So, and the high resolution ECWF, we haven't looked at that yet. That actually has a cyclone tracking right over us, and maybe mixed precipitation. Let's actually see if we have enough of the model output to see the totals for ECWF. Earlier, 2.9 or so. So,
That's the GFS again.
well, that's the GFS again?
ECWF might not have that as a variable at top.
Okay.
Or the 24
Total, let's go
hour.
to, total at this time. We'll just kind of take off a little bit from that. ECWF, that's the first one we're looking at, 3.8 as of 12. That's GFS though.
Or if you're-
Okay, there it is, 1.8. So it's really interesting. Some of the models have heavier, will track a little bit further to the south, heavier amounts to the south. This is a, let's say disappointing solution. I like snow. I don't mind a little bit of snow. Looks like a pretty decent event. Not over yet, hasn't happened, but I think the factors to watch for are going to be, in terms of accumulation, how cold can we get the ground? How intense can we get the snowfall itself? I think the one favorable thing is at least the GFS is continuing a trend to have the deepening occurring right over us, which is great, but we don't want to over deepen so that the low actually track, lots of the robust vertical motion all well to our south. That doesn't at this point seem to be the case. I'd rather be in this situation than a perfect track for the low, because anything that's perfect means a slight change is going to make it suboptimal, so this is probably a pretty good scenario. We have the potential for at least 1 to 3 inches of snow. And on the positive side, it can certainly be cold enough for it to be mostly snow. We could certainly exceed 3 inches. The downside, I think, is just where is it, the column the moistest, because if it's not particularly moist in the area where you can get lots of ice crystal growth, you're not going to probably see a significant not get the heavy snow. The one, I'll stop there with that discussion. Following the passage of this, we'll just go back to compare models a loop, and go to a single image. Go back to the GFS, 12Z run, and the surface map. And you can also bring it back to the continental United States too. National view. We'll see once this cyclone gets out of here, up a little bit, increase it tight, great. Once the cyclone moves out, let's go to 72 hours. It heads to the northeast, and that's pretty much it for it. The next, there is another area of warm advection coming out to our west, but that's probably going to overwhelm us and go well enough. We begin to warm up again, which is great. Feel like warmer weather, and just keep clicking ahead. You'll see that we end the week with another large cyclone developing to our north, but we do warm up before the cold air comes in. Forecasting for Saginaw again, we have another frontal passage on Thursday. So next week will be Thursday for Saginaw, and only rain. And then we get back into cold advection. This is much colder than what we saw before. In the following weekend, it's pretty quiet. Interesting East Coast development, but that's something we can talk about next week if it actually occurs. But the hybrid cyclone interacting with the front off the East Coast next week. All right. And that's pretty much it for today. Again, tomorrow, a little bit more sun than today. The clouds coming back in late afternoon. Snow arriving after midnight on Sunday morning. A period of light to moderate snow Sunday morning to Sunday early afternoon, and then things kind of quiet down after that. I would say right now, 2.5 inches would be my forecast for now. Cut it right to the middle. Anyway, that's it for today. Thank you, Pete. Thank you, Greg. Thanks for the comments from Andrew Quigley, our alumnus, and have a good weekend.